On page 2, we're going to start reviewing degree measure. A revolution is one full rotation of a circle. One circle is made up of 360 degrees. Okay, very important to remember, okay, throughout the entire class. One circle is made up of 360 degrees. Okay, so if we had like the XY plane here, okay, and we were trying to draw a 360-degree angle, so in standard position, your vertex would be at the origin, the initial side would lie along the positive x-axis, and then to draw a 360-degree angle, since it's positive, you're going to draw in the counterclockwise direction, and you're going to go one full revolution around. Okay, so basically it forms an entire circle. Okay, so that is a 360-degree angle. Okay, must remember, one circle is 360 degrees. So why the number 360? There are a number of theories for this, many revolving, no pun intended, around the fact that 360 is approximately the number of days in a year, how long it takes for the Earth to do one revolution about the sun. So that's a cool little fact. So what is 1 degree? Okay, 1 degree is basically 1/360th of a revolution. Okay, so if you took an entire circle, so if I'm looking back at this little picture that I drew, the entire circle is 360 degrees. So if I took this circle and I broke it up into 360 angles in standard position of equal size, one of those angles would measure 1 degree. Okay, so you're probably used to or familiar with using a protractor, okay, and looking at degrees this way. So every time you have one of those little tick marks, that's 1 degree. Okay, um, so hopefully, this kind of rings a bell from like a geometry class or something. Okay, um, one thing I want to mention about degrees, when you write down degrees, so like up here we had 360 degrees, and then right here we have 1 degree. When you are notating something in degrees, you absolutely need to put the degree symbol. Okay, why? Well, because like I said, we're going to be working in radians as well. And radians doesn't have units attached to it. It's just a number. So if you don't put the degree symbol on there, your angle could be misinterpreted as being measured in radians. Okay. So when you're writing down degree measure, you need to write the number and the degree symbol, which is basically, it looks like you're raising the number to a power, and that power is a little circle. Okay. Must put the degree symbol. Okay. All right. Couple of specific angles we want to talk about down here. We're going to talk about a right angle and a straight angle. A right angle is an angle that measures 90 degrees or 1/4 of a revolution, and a straight angle is an angle that measures 180 degrees or 1/2 of a revolution. Okay, so you've probably seen this before. Okay, so we're going to go to the bottom here and we're going to draw out a right angle and a straight angle. Okay, so we have a protractor here. Okay, on this first protractor, I'm going to draw a right angle or a 90-degree angle. So hopefully you've used one of these guys before. This is a pretty standard looking protractor, so kind of familiarize yourself with how it works. If you notice, the protractor is kind of 1/2 of a circle. Okay, so you could like complete this out, draw the bottom half of the circle, and you would have a full circle. Okay, so one thing to notice, remember there's 360 degrees in a full circle, and we're only dealing with half the circle. So if you divide this by 2, the protractor is going to have 180 degrees on it. Okay, so that's why, like, there's 2 sets of numbers. There's a top set of numbers and there's a bottom set of numbers. So if you look at either set, I'll focus on this bottom set. The numbers start at 0 and then they rotate all the way around to 180 degrees. Okay, so a protractor that you've probably used in the past, it covers from 0 degrees to 180 degrees. Okay, reason being because it's 1/2 of a circle. Okay. All right, so let's go ahead and draw the right angle, which is 90 degrees. Okay, you're gonna want to draw your angle in standard position. Okay, and maybe that's a little confusing here because you don't have an XY plane on here, but remember it's actually there. So basically, if you drew, if you look at your protractor, the very bottom is where the numbers, the very bottom set of numbers, you can kind of draw a line through here. I'm putting it in black here so you can see it a little better. But this is kind of how you're going to think of the x-axis, like right there. Okay, so let me notate that. You can kind of think of this as the x-axis. And then the vertical axis, you can kind of think of it through here. Okay, so like this might be your y-axis through here. And then hopefully that kind of helps you think of this, that you don't have an axis necessarily on here, but you can imagine that the XY plane is kind of transposed on top of this protractor. Okay, so to draw our 90-degree angle, it has to be in standard form. So that means the vertex needs to be at the origin. So right here at the point 0, 0. Okay, and then what we're going to do is we're going to draw the initial side. Because it's in standard position, the initial side has to correspond with the positive x-axis. Okay, so we will draw the ray like this. Okay, so where it lines up with the positive x-axis. Okay, and then to draw a 90-degree angle, you're going to do a rotation. It is going to be a positive angle, so you're going to have to rotate counterclockwise, so in this direction. Okay, and you're going to rotate through 90 degrees. Okay, so you're going to follow the numbers on the protractor. So since there's two set of numbers, there's an outer set and an inner set, you have to decide, well, which one should I use? Okay, well, the way it works is your angles, okay, are going to start when you start on your initial side. Okay, that's considered 0 degrees. And then when you rotate around half of a circle, then you should end up at 180. So we're going to end up using the bottom set of numbers. Okay, the reason is because if you use the bottom set of numbers, they start at 0 degrees. You want the initial side to coincide with 0 degrees, and then when you rotate in the the counterclockwise direction, you want it to end up at 180 degrees when you reach the half a circle mark. Okay, so we're going to go with the bottom set of numbers. And anytime you use a protractor, you want it to work this way. A lot of protractors are different. They're not all uniform. So you want to make sure that your initial side, the positive x-axis, goes through 0 degrees, and then it rotates through. If you cover half the circle, you end up at the 180 mark. Okay. All right, so let's go ahead and draw the terminal side now. Okay, so you're going to rotate in the counterclockwise direction. Follow your numbers. You're starting at 0 degrees and you want to rotate counterclockwise until you end up at the 90-degree mark. So your terminal side is going to coincide with the y-axis here. So this is a quadrantal angle because it doesn't land in a particular quadrant. Okay. When we have a 90-degree angle, okay, we usually designate it with a little square near the vertex. That's marking that it's a 90-degree angle. Okay, when we talked about the right angle, we said, yeah, it measures 90 degrees, but you can also think of it as 1/4 of a revolution. So if you look at the entire circle where I kind of filled in the rest of the protractor to make the full circle, the 90-degree angle kind of sweeps out. It covers 1/4 of the circle. So that's why you can also think of it as 1/4 of a rotation. All right, so now let's draw a straight angle. Okay, so we know a straight angle, it measures 180 degrees. Okay, so again, you're going to do the same thing. You can I'm not going to redraw it, but you can kind of think of the XY plane kind of transposed on top of this protractor. Okay, we're going to put our vertex right here, and then we're going to go ahead and draw the initial side, okay, of the angle. Okay, so the initial side has to coincide with the positive x-axis. Okay, so it needs to go through the 0-degree mark. Okay, we have another positive angle we're looking at, so the rotation will be counterclockwise again, so this direction. Okay, same kind of setup same protractor. So we're using this bottom set of numbers, okay? And so you're going to start at the 0 degree mark and you're going to rotate counterclockwise until you reach the 180 degree mark, okay? So if you did that, if you follow your numbers, you're going to go from 0 all the way, so 0 on the right to all the way to 180 on the left, okay? And so we're going to rotate this way, okay? And so your terminal side will end up over here, okay? So you're going to draw it this way, okay, so that you go through the 180 mark. Okay, so obviously you can kind of see why it's called a straight angle. Your angle formed, the terminal side and the initial side form a straight line. Okay, notice what else I did. Usually when we draw an angle, we draw a little kind of curve from the initial side over to the terminal side, and we put the arrow indicating the direction we went. So this is kind of showing right here, if you can see where my cursor is, that that we went from 0 degrees over in this direction to 180 degrees. Okay, so this is what a straight angle looks like. It's a line. Okay, again, if you thought of this as a full circle, okay, so let me kind of draw this in. You can see that when you draw in this straight angle, it sweeps out, or it covers 1/2 of the circle. So that's why up here in the notes you can think of a straight angle not only as 180 degrees, but as half a rotation. All right, so on the next page, we are going to continue to practice drawing angles in standard position, but hopefully now you see that we are starting to think of angles in terms of how much of a rotation or how much of a revolution, okay? Like 90 degrees, it's 1/4 of a revolution. 180 degrees, it's half of a revolution. So when we get to the next page, we're going to start using a 360 degree angle or 360 degree protractor, okay? That way we're covering the entire circle. All right, so let's take a look.